All right, today we're going to cover basic planetary processing for beginners. This is going to be the processing system that I use that I've learned over the past couple of years, but it's definitely more of a basic type of processing, but it will get you started and getting you some pretty decent usable images. You will need to go through this workflow. You will need Pipp, Autostakkert, and Registax 6. I'm going to link all three of those in the description of the video. All right, let's get right to it. I'm going to show you how to process a image of Jupiter off this data that I have here that I shot last night. So here's the data if you want to see what we have to work with. It's not in color because I recorded it without being debayered to save hard drive space. Okay, so the first thing we're going to do is we're going to open the program Pipp. I'll open up the screen so maybe you can see a little better. We're going to go over to File. Click File, then Add Source File. I have my data on the desktop, so we're going to have to go to the desktop to get it. Which I can't get to right now. There we go. Okay, Jupiter data. Here we go. We're going to click on Jupiter data. Select the video. It says right here, it's found out that this has a Bayer pattern of GRBG. Do you want to enable debayering? Yes, we do. Click yes. The screen pops up. It's going to show the debayered image and the size of the cropping, which right now is around 400. We're going to just close that. We don't need any of that. We're going to scroll down over here. Optimize options for Planetary. I'm going to now go to processing options. Usually everything that's set in here originally works well. If I've changed some stuff, can't even remember. But these are the things you want to check for. Frame stabilization mode should be set on object. You want to enable object detection so it will get rid of the frames without the object. Center the object in each frame. That's what you definitely want. And enable cropping. And what that does, it'll crop the video frames down to a preset size. Usually it uses 448 for planets. Just to, it'll make the processing go a lot faster because it doesn't have to process the full frame and the full image. Now what we're going to do before we process, we want to make sure that our settings are correct. So up here in the upper right corner, we will hit test options. So now it's showing a 448 by 448 frame with a correctly debayered Jupiter. It's actually exposed pretty well. It shows the max pixel value. 71 green, 62 blue, 67 red. That's pretty good. We're going to shut that down. We really don't need to do anything else, but what you do want to check, I know mine is set, but I know sometimes they're not correct. Output format, we want it to output as an AVI. So make sure that is outputting an AVI. Go to do processing. Now just click start processing in the top left corner and let it do its thing. This video is 5,000 frames long, and it's not going to take probably much more than 30 seconds to process it. It's already at 30%. Once it's done, we're going to take that video and then we're going to move it over to Autostakkert to stack the images and to analyze them and determine how many frames that we're actually going to stack. Also, if you keep your videos in a folder, it will probably automatically save the video that you're making here in your original data folder. So here it is, a video stabilized and cropped. You could play it and look at it. And there you go, perfectly centered. Makes stacking much easier. So now we will close down Pipp. Look at my Jupyter data folder. There it is, a Pipp folder. So that's what we're going to use for the next step. So the next step is Autostakkert. Run Autostakkert. You're going to have two windows. We're going to use this window here. Open. We need to open the one on the desktop that we just looked in, Jupyter data. Here we go. We're now going to click on the Pipp file that we just made. Click on the video. Okay, now the video is loaded into Autostakkert. First thing we're going to do with Autostakkert, at least what I do, hit Analyze. What's happening now is it's looking at all the frames and sorting them by quality. When it's done sorting the frames by quality, it's going to put out a graph. The graph is a little confusing. I think I've sort of figured it out. It's hard to find instructions about the graph, but I'll explain what I do and why I do it. Hopefully it makes sense, but it's been working pretty well for me. Depending on your computer, it could take a little bit of time, but mine is almost done, and this is a pretty old computer. Okay, there's the quality graph. Now, it shows in the beginning here, the frames were good, and then the quality dropped, picked up. This is definitely from the seeing. Picked up, dropped, picked up again. So what I've been doing here to choose how many I want to stack is I want to stack the ones that are above the 50% threshold. Everybody has their own standards. Depends on the seeing, how good. I've had ones that were all up in this section before, so you could stack almost all of them. But what I've been doing now is I follow this green line, and where it crosses 50% is how many I use. Each one of these blocks here is 25%. So this crosses the threshold just after 25%. So say we'll stack 27% of these frames. Next, after I type in 27 over here, this would be the percentage I want to stack. I come back to this window. We want to put a grid pattern on here. I usually do it automatically. This is the scale of the grid. I usually, depending on the size of the image, that will depend on the size of your grid. These are small images, so 24 usually looks good. That's what it looks like when I use 24. Now if I use 48, you can see it uses much less points and are spaced out more. That'd be more useful on a much larger image like a complete moon or something. Sometimes even 100 is good for a moon. But since this is a very small image, we're going to use small, place the AP grid. Now we have a lot of data points to stack. We've confirmed again that we want 27% stacked. Output is a TIFF. I haven't changed anything. I don't really touch anything in here. It's set for planet over here. Drizzle, these can enlarge your image if you have a really small image. I've had mixed results using this. If I drizzle 1.5 times, it'll make the image 1.5 times bigger. And sometimes it looks good, sometimes it makes it look pixelated. The image scale I used for this image is pretty good. It was 2650 millimeters f/15 7-inch Meade Maksutov telescope. So the size is pretty good. So we're just going to stack it as is, hit stack. Now it's going to run its process, goes against a reference image, aligns the image, stacks the images, then it recombines the images, and it's going to automatically save an image and a file inside where we just got this picture from. So now in the Pipp file, there will be also the Autostakkert file. So at 38%. I've had some of these take a long time. Planets usually go pretty quickly. They're small images. But when you're doing full size, full sensor moon images, like with a DSLR, it can take quite some time to stack these up. Alrighty, it's just about done. Save, done. That's it. We're now done with Autostakkert, so we can close that down. We will look in our data folder, go back to Pipp. This is the one from Autostakkert AS, and it always says P. The number will be the percent, or this percent you've stacked, 27% of 5,000. So here is the stacked image with nothing done to it. You can see a decent amount of detail, but it's not too sharp. It's a little blurry. Jupiter's only at 26 degrees when I took this. Not optimum at all. Plus the seeing was not very good, as you could see in the beginning how wobbly the video was. So now we're on to the third step, Registax. We will open Registax. Up in the left corner, we hit select. It always opens to the last thing you were in, so we're going to go back to the desktop and look for that folder, Jupiter data. Then we go into the Pipp, go into the Autostacker output, click on that. It says, do you want to stretch and test intensity levels? I always click yes. It doesn't seem to make that much of a difference to me, but that's what I do. Next thing I do, okay, now we're all loaded into Registax. Looks very daunting, a lot of controls. I don't use a lot of the features of this program. I just use it for sharpening and RGB align, and a little bit of color alignment, sometimes rotating the image. So the first thing I'll do, we'll go to the right, up to the functions. First thing I do is view zoomed. I like to open that up. This is going to give me a little closer view so I could see the planet a little better. Step 2, I'm going to go over to RGB align. This is one of the most important aspects of this program besides the sharpening. The lower the planet, if you notice, sometimes the edges of the planets will be red and blue. It's atmospheric distortion because the red and the blue are not focusing with the green. So by doing an RGB align, the program tries to estimate the best it can and align all the channels together. And you will see the Jupiter get sharper as I align the channels. What we can do here is click RGB align, move this box over. We need to make this little green box fit the planet. There we go. So now it's going to scan this area here and automatically recorrect the RG and B. All we have to do is click estimate here and let it run. If you look down here in the bottom left, it's counting up, it's checking the red channel, and then it's going to check the blue channel, and it will recorrect them. And if you watch the image, when it finishes, it's going to get sharper, which should be right around now. Wow, and it didn't align anything. Let's try that again, because I'm pretty sure the alignment's not right. And when I did this last night, it changed. I guess it's saying it's okay. I could have sworn last night it was off, but according to this, it's good. Now I go to RGB balance. Usually auto balance works pretty well. I'm not sure if I like that color or not. It's up to you. Becomes kind of artistic at this point. just for the demonstration, we'll leave it like that. Close the window. Now, for the interesting part, the tricky part, the wavelets over here on the left. What I like to do is lower these numbers from 100 to 80. The reason I do that is you have more sensitivity from the slide. Actually, I should say it makes the sliders less sensitive. When I slide the sliders, it sharpens it up, but it also, you can't move them that far without making wide swings. So if I move these down to 80, they're not so sensitive, and you have a little more room. It's like using a focuser with a 10-to-1. I'm just making the controls a little finer. The first layers do the most obvious details, and the last layers do different details. Like farther in the back, they don't do as much. So I'll start in the front. We start to gently slide it up. You could clearly see the planet sharpening up. You can start to see the moon, I believe it's Io, showing up more. I think I'm going to go right around there. I don't want to go much more than that. Usually you end up going farther on the first one and going less on the others. Sometimes you go more this way at an angle. It's all basically how much your image can handle. That looks decent. And then usually it's bottom ones. Going around 4 for me with my data usually works pretty well. But it's all subjective. Every image is different. No two are the same. We have a good amount of data here. Decent amount of detail. You can see the moon. The only thing is upside down. I don't like that. If we have here, we have denoising. If you slide it up, it'll add some denoising in to smooth it. The thing is, the more you denoise, you start to lose some detail. It just, if you notice, it just got a little blurry at 0.10. So maybe add 0.5s if you want. Usually after Registax, I go over it with like another photo editing program, but you can get satisfactory images just right out of here without doing much more. The last thing I usually do is I go into flip and rotate. It needs to be flipped 180 degrees. There we go. That's the right orientation. And I believe the moon is supposed to be down over here, so we could use a little rotate knob. I have to put it back here. This way it's facing, and I'm going to rotate it to the right a couple degrees. That looks about right for the way Jupiter was when I took the image. You could check your Stellarium or whatever apps you like for looking at stuff and checking out things. I use Celestron's program. Sky Portal. That's my personal favorite. That's what I use. There we go. It's all rotated. It's done. There's lots of other stuff we could do in here. I don't do much more in here because other photo editing processors kind of do a better job. I'll go over it quickly. Obviously, we have contrast and brightness on the right. We can slide them around a little bit. Gamma, you can play around with. It's basically curves. But we can do these in other programs. Sometimes we can brighten it up a little bit. Maybe darken up the background a little bit. We can add a new point by right-clicking. There we go. Not too shabby. Say we'll just leave it like that for now. And that's pretty much all there is. There's a lot of other things you can do with this program. I haven't messed with all of them, but you could even stack with this program. But I feel an Autostakkert works a little better, and that's what most people say. I haven't done a head-to-head comparison. So next step, do all up here. It's already highlighted green. It's going to go from what we started with. Apply everything we did to all the frames. Save the image. We're done. We'll call it Jupiter. Jupiter. Maksudov. Save it as, I save them. You can save them as, I guess, whatever kind of file you want. If you want to save space, though, just save it as an 8-bit JPEG. Save. I usually minimize it just in case for some reason it doesn't save, even though I know it did. Now that's going to be also saved in here. It's going to be saved inside the Autostakkert file. There it is. We can compare the two. There is the stacked image with no processing done to it. And there's the processed image on the right. So you can see how much difference there is just from adjusting the wavelets. So that's basically all there is to your basic processing workflow. And I hope you got something out of it. I will put links in the comments or in the description of all the software you need. Thanks for watching.